Here we have four images: an aircraft, a sailing boat, the cockpit of a big ship, and a treasure map, a map. Can you tell what do these images have in common as far as navigation equipment that they use? You have 1 minute to talk about it. All use a compass and a map to find their position or navigate to a destination. Now today we are going to talk about bearings, and let's see what you have to learn about bearings. You must be able to measure and draw angles to 1 degree. You must be able to use bearings to specify direction. You must understand the rules of bearings. You must understand how to calculate back bearings. Recall and use the 8 points of the compass and their 3-figure bearing. And you must be able to use 3-figure bearings to specify direction. To use a compass and a map, you must know how to take bearings. In other words, to know how to measure angles. Let's first recap the compass points and then learn how to take bearings. So we have a compass, the basic points: north, east, south, west, and northeast, southeast, southwest, northwest, and the degrees of each of the points of the compass. A bearing is a way of defining direction. It's an angle measured from north in a clockwise direction, written as 3 figures. If you see a bearings question, north 3 figures in clockwise direction, you have to remember that. Copy this in your workbook. Having 2 positions A and B on a map, we want to find the bearing of position B from position A. We draw a north line at A. We draw a straight line between both points, and we measure the angle between. So in other words, if you are at position A facing north, by how many degrees must you turn in a clockwise direction until you are facing B? So we're gonna try an experiment. We assume that the wall in front of you, where the board is the north direction. When I will tell you, all the class will stand up, close your eyes, and I will give you a bearing. Then you will turn very slowly to this bearing. If you feel you cannot do this, if you might feel dizzy or if you cannot stand up, you do not have to do it and you can stay seated on your chair. Ready? Stand up. Close your eyes. We start the experiment. Turn 090 degrees. Open your eyes. Okay. Face the board again. Close your eyes. And now turn to a bearing of 135 degrees. Very good. You can sit down. Measuring the bearing of 1 point from another. To find the bearing of A from B, we draw a north line at B. We draw a straight line between both points. We use a protractor. And we measure the angle between in a clockwise direction. In this case is 240 degrees. So we have the first worksheet. And we'll see the answer to that. So B to A is 45 degrees and northeast direction. And we can see all the other questions. Now, the second worksheet, we want to find the bearings of Brussels from London, Paris from London, Dublin from London, and Manchester from London. So let's see, we draw a north line at London. We use a protractor and we measure the angle is 102 degrees. So from London to Paris is 150 degrees. So from London to Dublin is 295 degrees. And from London to Manchester is 325 degrees. Fixing position. If the navigation equipment fails, pilots can find their position by calling controllers at two different airfields or airports for a bearing. The two bearings will tell the pilot where he is. So we have the airplane. He contacts airfield A, which gives him a bearing of 50 degrees. The pilot draws the line on his map and then does the same with a bearing of 300 degrees from the other airport. So what does the pilot say to the controllers? Thank you. Same example with real airports. We can see a similar case, same numbers, and we placed it on a Google map with Heathrow Airport and London City Airport. Now the third worksheet, we want to find the position of a point C if it's on a bearing of 045 degrees from A and 290 degrees from B. So we place the protractor in point A, we draw the north line, we find the 045 degrees, we draw the line at 045, and we do the same with point B. So point C is the intersection of the two lines. So worksheet 4, we want to find the position of a point D if it's on a bearing of 120 degrees from A and 220 degrees from B. So we place the protractor in point A, we draw the north line, we find 120 degrees, we draw the line, and we do the same for the 290 degrees from point B. So point D is the intersection of these two lines. Back bearings. The bearing from a point A to point B is 90 degrees. So what's the bearing from point B to point A? So if we want to return, we go from A to B and then we want to return from B to A. So this angle is 90 degrees and the straight line 180. So the sum is 270 degrees is the back bearing. So another question on back bearing is from A to B is 105 degrees. What's the bearing from point B to point A? So we join the two points with a straight line. We have corresponding angles. So this angle is 105. This is 180. So the back bearing is 285. Another practical application is a boat is sailing at night and the captain wants to verify the boat's position on the map, point C. Identifies two lighthouses, A and B, and takes two bearings. The bearing of the lighthouse in position A from C is 230 degrees, and the bearing of the lighthouse in position B from C is 95 degrees. So we place the contractor, we draw the north, we join the two points. So these alternate angles, 50 degrees. And we have the first line, and then we do the same with the bearing from the other lighthouse. Also 95 plus 180 degrees. So the bearing is 275. So the intersection of the two lines is where the sailing boat is at that moment. This is a quote. A highly developed value system is like a compass. It serves as a guide to point you in the right direction when you are lost. Thank you.